Hello children, welcome back to my next video. So in my earlier video on sound, if you recall, if I've gone through that video, you can see here there are some properties of sound wave which are written here, or properties of wave. So today we'll be discussing in this video about the properties of sound and the equations, how to derive two related equations which can be derived with the help of these properties. So first we'll be discussing about properties of sound. So the first property of sound is called loudness. So loudness, you know that your TV loudness, your television set, you can increase the loudness or decrease the loudness with the help of the volume switch. So on your remote you have a volume switch. So with that volume you can increase the loudness or decrease the loudness. So what does loudness means? Loudness is the property of sound which helps us to distinguish between either a loud sound or a soft sound. So whether a sound is loud or whether a sound is soft, that can be distinguished with the help of this property. Now any kind of properties of sound that we will discuss depends on the properties of the wave. So here also loudness depends on the amplitude of the wave. That means more will be the amplitude, louder will be the sound. Okay, for example, there is a drum and you're beating this drum. So when you want to hear a louder sound, you'll hit the drum very loud. For example, this table, I'm making a soft sound now. If I want a louder sound, I'll be hitting it harder. That means the amplitude of the vibration of this layer will be more. So suppose this is one wave and this other wave. Both the waves are having equal wavelength, but the difference is that this is having a lower amplitude, so this is a soft sound. This is having higher amplitude, so it is a loud sound. So loudness of sound is measured in a unit which is called decibel, represented by dB. Now let me tell you one interesting thing about the properties of sound is that properties of sound are relative in nature. Relative in nature means they will depend based on the whether a sound is loud or it is soft. It will depend not only on the amplitude, but it will also depend on the surroundings. For example, inside a hospital ICU, even if you drop a small container, that will be a loud sound given the peaceful surroundings. But if in a rock concert you shout at the top of your voice, even that does not seem to be a loud sound because the surrounding itself is so loud. So therefore it is relative in nature. The next property that we are going to discuss, it is called the pitch or shrillness. The next property of sound, pitch or shrillness. Now what does pitch or shrillness means? So pitch or shrillness is the property of sound which helps us to distinguish between high pitch piercing sound and low pitch deep sound. For example, you know male voice, how deep they can be, whereas female voice are very shrill. Now why it is so? Because it depends on the frequency. Okay, so high pitch piercing sound and low pitch deep sound, it depends on frequency. So more will be the frequency, more high pitched will be the sound. So before trying to understand the distinction between male and female voice, let's have an example. So suppose this particular wave, it is completing one wave, and suppose this wave, the other wave, 1 and 2, and suppose from here to here they are completing the waves in 1 second time. So this particular wave is completing one wave in 1 second, so its frequency is 1 Hertz, and this particular wave is completing two waves in 1 second, so it is 2 Hertz. So there is a low pitch sound, there is a high pitch sound. So when we are trying to understand in terms of male voice and female voice, in case of male voice, you know voice is created by vibration of the vocal cords present in our voice box. So this is the neck portion. So in the neck portion we have the vocal cords. So in case of males, the vocal cords are quite long and therefore the frequency is less, but in case of females have a shorter vocal cords, so their vibration is faster and the sound which you can hear is much more shriller. Now in terms of music, we use the term bass for a low pitch sound, which is very having deep bass, we say when the sound becomes like this, and another term is called treble. when the sound becomes very shrill in nature. Okay, ting, like that. Now you can do one activity at home. Suppose you have a table like this, and suppose there's a table, and at the edge of the table you hold or you press a ruler. Okay, a plastic ruler it can be, or it can be a steel ruler. Steel ruler is more, it will give you more good results. Suppose initially this much length, you bring it down and you release it. So when it will vibrate, you'll hear sound. In the next case, what you do, suppose this the edge of the table. In the next case, you make the length of the ruler more. Okay, you take the whole length of the ruler. At first you take half the length, suppose. In the next case you take the whole length and you press it here very tightly, and then you make it vibrate. So you'll find that when the length is less, the sound becomes much more shriller. Then that means the pitch is higher. Same thing if you have a guitar in your home. Those of you who play guitar, you'll know that when we come to lower frets, because suppose, let me draw. Suppose there's a guitar and these are called frets. So, and these are the wires. Okay. Now, suppose if you press your finger here and you pluck the string, you will hear one sound. And in the next case, you lower the fret. Suppose you press here and you strike the string. In this case, you will find that the sound becomes much more shriller. It becomes like ting, 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 like that. So that means what? The lesser is the length, more will be the frequency, and shriller will be the sound. But if you are holding it in higher fret, the sound will have lesser frequency, and so the pitch or the shrillness will be less. Next we come to another interesting quality of sound, which is called timbre or quality property. So what is timbre or quality? Suppose you are listening to a musical piece, a musical let's say a musical piece on your music player, and there two instruments are being played. Let's say one violin and another one, let's say, a drum. Now for both violin and drum on your music player, you have the same volume switch. That means both are being played with the same amplitude and same loudness. And for both, you'll have the same bass and treble switch. That means both the violin and the drum, you're listening with the same shrillness or same pitch. But in spite of that, we are able to differentiate. We are able to make difference between which is the sound of violin and which is the sound of drum. The reason is that their quality or timbre is different. Okay, so what is quality or timbre? It is the property of sound which helps us to distinguish between two sounds coming from two different sources. So the source were different in the example that I gave you. One was the violin, another one is the drum. So the sources are different, and even if they have same amplitude and frequency, we can distinguish them. And it happens because of the difference in the pattern of the wave. So let us try to understand with the help of wave, the wave diagram. Suppose there is one wave, and suppose this is another wave. So both the waves are having the same wavelength. Both the waves are having the same amplitude. That means same loudness. Now if I say that suppose from here to here it takes 1 second time. So both are having the same frequency as well, 1 Hertz. This is also having 1 Hertz, this is also having 1 Hertz. But what is the difference that you can see in both the waves? The difference is that both the waves are having different patterns. So it is this quality or timbre which helps us to distinguish even between noise and music. So when it will be noise, the wave pattern will be very erratic, unpredictable. Sometimes suddenly it will go up, suddenly it will come down. So that is called noise. But when we come to music, then it has a definite pattern, it has a rhythm in it. So that is called the quality or timbre which helps us to distinguish between noise and music. Now again it is relative for some fellows, like this can be music. If you have very hard rock music where suddenly the sound goes up all of a sudden, suddenly the music stops, and for those people again classical music can be a noise sort of kind of thing. So it is always relative. It is upon a person's perception, how you are perceiving it. Okay, now we'll be deriving the equations, something more technical related for your numericals. So suppose we consider one wave. There's one wave, right? So what is the length of one wave? In numerical terms, if you can see, it can be 1 meter, 2 meter, 100 meter, 5 centimeter, whatever. That means what? It is a variable. So let us take it to be lambda meter, because the lambda will be the most suitable variable. We can take x meter, the most favorite variable in maths, x, y, z. But instead of taking x, y, z, we have taken lambda because we represent lambda as wavelength. Sorry, wavelength is represented with lambda. So that is the most suitable variable we can take, because one length of one wave will be a wavelength. So we take it as lambda meter. This value can be anything. And how much time does it take to complete one wave? It is your t seconds. It can be any second, 5, 4, half a second, whatever. But the most suitable variable will be capital T. Why? Because the time required for one wave is called time period, and the variable to represent time period is capital T that we use. So let us go by this definition, that frequency. What is frequency? Frequency is the number of waves, n number of waves completed in 1 second. So we can write this statement like this, that n number of waves are completed in how much time? 1 second. So if n number of waves are completed in 1 second, therefore one wave will be completed in how much time? 1 by n seconds. Simple unitary method. So like 5 pens cost 20 rupees, 1 pen will cost how much? So n number of waves completed in 1 second. So one wave will be completed in 1 by n second. Now if you look at this underlined portion, one wave is completed in, so it is the time taken for one wave. Now what is time taken for one wave? It is the definition for time period. So time required for one wave is nothing but time period. So this thing we can replace it with what? Capital T. So capital T is equal to 1 by n. So we get the formula T is equal, capital T is equal to 1 by n. Or conversely, if we write that, n is equal to 1 by t. Now we come to the next formula. So time required for one wave, I told you t seconds. Distance of one wave, how much? Lambda meter. So what is the definition of velocity? Distance by time. So what is the distance here? Distance is lambda meter and time is capital T, t seconds. So V is equal to lambda by t. So this can be your one equation, and another equation is there. V is equal to lambda by t we have got. So this t, if we take out, it is a denominator, so it can be written as lambda into 1 by t. Okay, so this 1 by t, what did we get 1 by t as? N. So 1 by t can be replaced with n. Okay, so V is equal to lambda into n. So that is velocity is equal to wavelength into frequency. So these are the very simple equations which can be used for numericals related with sound. Thank you so much. If you like the video, do subscribe to my channel and hit the bell icon for further notifications. Thank you.